Alright, YouTube, Cordless here. I'm back. I'm delivering pizza. My daughter's 15th birthday today, so I agreed to deliver her some pizza to school, and so that was what I was doing just now. So apologies for the interruption. I was trying to get started before, and my phone did its thing, and I figured I'd have enough time, and it didn't, so that's okay. I tend to blab on a bit whenever I'm talking, so that's also a problem. So just to kind of recap, so this is part 2 of a video talking about applying Lightning Network to API calls on web services. And the Lightning Network is currently going to be built on top of Litecoin, which is getting SegWit deployed on it in its code base, which will enable the patch for malleable transactions that currently plagues both Bitcoin and Litecoin. Malleable transactions, again, it's not something particularly to be concerned about, and I'm going to talk about concern of cryptocurrencies here in just a second. But having a malleable transaction is not a big deal as long as the transaction gets closed at some point. It's really when it's not closed yet. And what do we mean by closed? Well, so closed is actually where a transaction, and you just have to kind of imagine a transaction as a piece of data that has been signed by two people holding crypto keys. Now, cryptography keys are certainly an important topic here, and I'm kind of skimming over a lot of that in this discussion because it's not really what the discussion is about. Discussion is more about us as people, humans, dealing with technology in a trustworthy way. And crypto keys are a way of encoding some data with a key, such that you have to have another key, a private key, to unencode it. So you could take, for example, I could put my public key out on the internet, depending on what kind of key it was, put it out there on the internet, and then you could take that key and encode some data with it, and then send me that data, and no one in theory, if it was a good cryptography, no one in theory could unencrypt it. Now, some encryption schemes over the years have been shown to be less than ideal or less than secure, and in fact, there was a very recent sort of big deal, which was this revelation that some of the SSL connections on the internet, and SSL is wherever you have HTTPS on your web URL, that when that's encrypted, that the encryption means by which that data is encrypted and sent to you, that key that was created was actually created using the same seed for about 40% of the websites on the internet. This is just recently. And it came out that the US government hired or built a team to be able to actually crack that one key, which took an awful lot of compute power, and the assumption is that they cracked that key and then were therefore able to read all of the data being transferred from these 40% of websites on the internet to the clients or the web browsers that were hitting those websites because they had cracked the key. Now, if somebody had written some software to actually use the encryption the way that it was intended, right? Again, a human got involved with this, right, and made a mistake or made an irrational decision, then they wouldn't have done any good to crack that key. It would have just been one key for one company, and nobody would have spent the amount of time required to be able to crack the key because it wouldn't have been useful to them afterwards. But whenever someone figured out that it was affecting 40% of the websites on the internet, they decided it was a good idea, and they went and did it, and it was worth it. I guess they thought it was worth it, right? I don't know if it was worth it or not. Seems like maybe violating people's privacy is not worth doing, but maybe they justified the means for it. These types of thought processes, I call them, and again, I don't know if you can see the board real well, but I'm just going to assume you can. I call these thought processes irrational sometimes, and that's compared to rational thought. And this is very important for this discussion because what I'm talking about is actually applying a rational human thought to the problem of irrational human thought by solving it with rational computed thought. So cryptocurrencies are rational. Whenever there's a value in the blockchain and it has been validated by miners in a way that consensus is reached in that moment, once that's been done and it's been closed, it's forever validated that that's happened. And the amount of work required to undo that one transaction, it's a lot of work. It's more work than has ever been spent doing anything on this planet. So it's well worth imagining that it can't be done, but it's not to say that it couldn't be done. It would just require an awful lot of work to do that. And in fact, that's what irrationality is. When I say things are irrational, I actually mean there's a questionable amount of work required to determine truth or facts. What's factual or what's real. So once something goes in the blockchain, for example, and it's closed, that's the important part, by miners on a blockchain like Bitcoin, and it's closed, it's truth or factual. Everyone has agreed, all the irrational people in the world have agreed that this is factual when something is rational. That's essentially what rational means. Now, I'll give you an example. A circle, I can tell you how to draw a circle, and I can tell you how to compute the ratio on a circle compared to its circumference or diameter, right? And I wrote pi there, but that's actually not it. This would be the diameter. But there's a value, and there's a variety of calculations. You can calculate the area, the circumference, the diameter, the radius of a circle based on pi. And pi is 3.14159, blah, 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 blah. And I can tell you how to calculate this number. I can give you an equation, which I'm not going to do, but I could give you an equation that you could use to calculate pi out to so many digits. I was driving back here and I realized the tires on cars are not round. They approximate roundness, they approximate a circle, but they are not themselves round. They get flat on the bottom, and there's like bumps and stuff on them, but they're not round, right? But if you wanted to create a perfectly round tire, you would have to do a lot of calculations. So it's irrational. Pi is irrational because in order to calculate a given digit of pi, in other words, to arrive at the truth of a given digit of pi, you have to do a good amount of work. And if you need one way down the chain, I say chain, the pi chain, the string of numbers down pi, then you're going to have to do basically an unknown amount of work to get there. Now sometimes you can try to figure out about how much work it's going to do, but it's still a lot of work. It means there's a lot of work in the future. So it becomes irrational because of that. There is no end to that. You don't know how much work you have to do to get to the end of pi. In fact, there is no end to it. You calculate it all day long, all the way to the end of the universe you could calculate it. And you're not going to get to the end of it because it's just going to keep on going. So an unknown amount of work to arrive at a truth of something, the value of pi. Rational truths are truths that you can arrive at in a predetermined amount of time. So for example, if I look at a value in the Bitcoin blockchain that has already been closed by miners, well, it's rational. I don't have to do any work. It's a known amount of work. Well, I looked it up and there it is, and that's the value, right? So whenever you start talking about using Lightning, the key here is with Lightning is that it's built on top of a rational system, but itself is built with rational components that are tied to irrational actions by irrational actors. That's the key here. So it doesn't mean to say that when something is irrational that it's not trustworthy. That's not what irrational means. And a lot of times people associate someone that's irrational with someone that's insane or crazy. But that's not really what I'm talking about here. I'm talking about having a known amount of work for a rational thought is a known amount of work. For an irrational thought, it's an unknown amount of work. But it doesn't mean that it's a lot of work. It could be a very short amount of work. I just don't know how much work it's going to be. So whenever people get stuck in traffic, let's say you're driving to work, right? And your normal route is blocked. Somebody's doing construction on it. They decided randomly to dig up the road and fix it because of whatever reason, right? Water pipe broke or something. And you have to go around, right? Or you can sit there and let them, kind of share the single lane road that they've got, but there's trucks coming in and out. Well, you don't know how long that's going to take. And if you're late to a meeting, you may choose, irrationally, to believe that going around is a rational option. And the reason humans are going to choose that is because you're going to believe that if you go around this route, you know how long that's going to take. So for sure this. It's known, right? It's a known truth. And something that was a known truth is no longer a known truth. It's a big question mark, right? And a lot of times people will just go around just so that they can know how long it's going to take, even if it takes longer. And because they don't know if it's going to take longer or not, that's also irrational. They don't want to do that, so they're just going to go around. But some people will choose to stay on the road and wait, assuming that maybe they're not going to have to wait as long, or maybe they just don't care. Maybe they're not in a hurry, right? And they just choose to be rational and sitting there and saying, I'm not going to worry about it. I'm not going to try to figure out if it's going to take longer or not. I'm going to let it take longer. It can't take forever, right? But on the way over to the school to deliver the pizza, that's exactly what happened to me. But I was in a hurry. And so because I was in a hurry, I chose going around a known route. I knew how late I would be. I was 3 or 4 minutes late, right? Wasn't a big deal. I got the pizza there. That's what mattered. And all that mattered to me is that I was okay with that. And so that's the way the Lightning Network works, is that these transactions, I don't have to explain how the Lightning Network works. If you trust the people that I'm going to link to and what they're saying about the Lightning Network and the Lightning paper, if you trust those people, which I do, I'm telling you I trust those people. Now, if you trust me and you trust them because you trust me, well, that's all irrational. You have no idea how much work it is to actually figure out whether you can trust them or not. But I'm telling you, you can trust them. And the reason why I'm telling you you can trust them is because I know, and you can go verify for yourself, that the Bitcoin or Litecoin network is trustworthy as long as a block has been closed. Currently. And it appears that when Litecoin goes live with SegWit, that you will be able to trust that a block or a transaction that is submitted to be closed at a future date will not be able to have its transaction ID changed by somebody later on. And that is going to have to be trusted by listening to a variety and sundry of people and maybe analyzing the code and all those things. But that's that trusted rational layer that I'm talking about. We're getting ready to put a layer on top of it that is not so rational, which is the Lightning Network. And the reason it is not so rational is because you can have this back and forth conversation between the actors who are themselves irrational humans. That they're going back and forth, that you can have this sort of, well, you do this, and I'm going to do this, and you do this, and I'm going to do this, and okay, are we all settled? Are we agreeing on this? And then somebody can go, I don't agree with that. And then you can go back to the last time you agreed on it. And whenever you do come to these moments of agreement, where both parties are acting in a rational way, then you can quickly stick it on the blockchain, and it can become trustworthy at that point. It can become rational. So it's a means, the Lightning Network is a means by which irrational actions become rational or collapse if you will, collapse into rationality. So and I'm going to restate that so I don't use rational at all. It is a means, lightning is a means by which humans can come to an understanding of unknown amounts of work arriving to a known amount of work and then settling on that and moving forward. Right? It's about getting things done is really what it's about. Making decisions and moving forward. So these payment channels are going to have people who try to rip each other off. It's just going to happen. There are irrational actors in the world, and irrational actors intend to be irrational in order to screw people up. That's their intent. That's their function, if you will. And when we say they're an actor, they're acting that part of being the irrational person, the irrational entity. In fact, their purpose may simply be to spread further irrationality into others to disrupt the network itself so that rational outcome cannot be made. But if we do this right, and we apply it to the right things, it means that we will actually cause them to be, we can cause that intent of spreading irrationality into the aggregate, into the group that is using this technology. We can actually cause them to make it to where it's too expensive to do that. If they want to spread irrationality into the network further, well, then they're going to have to pay for it. They're going to have to pay for that right to spread their irrationality into the network. And at some point, we're going to force them to close that block and put it in the chain so that it becomes completely rational. Okay, so I hope that makes sense because it's an important topic here. The lightning paper touches on this in a slightly different way. They talk about trees falling in the woods, and if no one's there, did the tree fall or not? And if people agree that the tree fell, that's all that really matters. That's sort of the same thing that I'm talking about here. I'm just putting words, names to it. I'm putting labels on it. I'm saying it's irrational. It's an unknown amount of work to be done in the future. Irrational is a known amount of work to be done in the future. Okay, enough about rational and irrational. People who know me probably are tired of. I've been talking about this a lot with some of my peers, and I tend to drag things into the ground because I'm trying to understand them in simple terms. So I try to simplify things. So we have this situation now where we've established that the lightning network can essentially you can open a payment channel, and what you're doing again in these payment channels is you're signing transactions. And these transactions, that's what's happening in these payment channels. And these signing of transactions, the transactions eventually, at some plus t time, will eventually get pushed into the blockchain and closed. Which means they become firmly embedded as a truth in the blockchain. So if you sign a transaction that says you're going to give somebody some Bitcoin, and they sign the transaction saying, yes, I accept your Bitcoin, and there's no other payees, and there's not any other code that gets run, Bitcoin and Litecoin both have a code that can be run whenever a transaction is being processed called script, then that means that money is going to be transferred and permanently, I say money, that value in the chain or in the ledger is going to be updated in someone else's favor. So this can also be done, so we have Alice, and then we're going to take Bob, and we're going to make Bob an intermediary, and then we're going to take Charles, and we're going to make him another payment channel. And so what can actually happen here is that Alice can start a payment channel with Bob, and Bob can start a payment channel with Charles, and then they can exchange values, and Alice and Bob can exchange values, which then allows Alice and Charles to exchange values. And I'm not going to go into the details of how all this works. It gets a little complicated, and again, I'm going to link to the other video on Lightning that is actually explained by somebody who is technical that will explain this to you. And you can also read the Lightning paper as well. It goes into details on how to do this. I'm not here to explain the details of those to people. That's not why I'm doing this video. I'm not here to explain the details behind why I think Bitcoin's a good idea and why I trust the technology. A lot of people do not trust the Bitcoin technology because they're being irrational about it. They think that if they spend an unknown amount of time thinking about how Bitcoin is not a valid technology, that they will somehow prove that it's not valid. And they are all going to be wrong because there are rational ways of understanding Bitcoin technologies, and there are rational ways of understanding Lightning. And the Lightning authors have not stated that they believe that it is 100% rational to believe the Lightning Network is secure. It is currently not even in production on a chain, right? We're getting ready to see that happen here shortly, just in a few weeks. So they themselves have limited these types of transactions, these payment channels, to $20 at a time. So we're really not talking about a lot of risk here. When you talk about money, something that's like a dollar, I mean, a lot of people like to think, well, dollars are rational. I mean, I have $20 and I know how much this is worth. And the reality is that's true. In a given moment, like in a given day, if you're in New York City and you have $20, you can buy X many hot dogs. But that's not going to necessarily guarantee that 6 months from now you're going to be able to buy 20 hot dogs. Something horrible could happen between now and then, or something wonderful could happen between now and then, right? Something wonderful like a glut of hot dogs appears on the market and hot dogs prices plummet, and well, then you have utopia, right? Free hot dogs for everyone, and $20 no longer buys those hot dogs. So things change over time. So it's in a given moment, and that's the key here with these $20 on a payment channel. In a given moment, the biggest risk you've got is not having your entire wallet cleaned out. It's actually losing $20 at the most. And the reason why it's currently that is because, well, there's a question mark here. Is this thing going to work the way that it's advertised with the code base that is there to implement it? It's not that the idea itself is bad. The idea is sound. It's whether or not the implementation of the idea is going to work or not, and whether or not that gets coded up correctly by the people. That's a big question mark, right? We know that if you code it up and then you're clicking along and then all of a sudden somebody figures out something, well, I mean, the worst case, they might be able to get 20 bucks from you. Or if you didn't know and you kept doing it and you didn't realize something was happening, you were losing your money, you weren't getting your cups of tea or your API calls, for example, then you might lose a little bit more, but it's limited. You're not going to lose all of your Bitcoin if Lightning is not, code base is not initially that secure. It's not that big of a deal. It's something that is built on top of something else. When you talk about building on top of other technologies, you're relying on the underlying trust of that technology that's at the bottom of the stack, which in this case is Bitcoin or Litecoin. All right, so we've kind of established here that you can have an intermediary that runs the payment channel destination. So if we were to look at, I'm going to kind of veer away from Lightning for just a minute. I think I've explained it enough. Is that when you have an IP address that's visible on the internet, there's a couple of different ways that you can inform people where this is, and one of them that's very popular is DNS. So if you need to know where somebody's address is, you can do a DNS query, and in order to do that, you need a name like www.google.com, for example. And you do a DNS query, and typically DNS queries are done from the computer that you're on to a DNS server somewhere. If you haven't typed in DNS server's address, it's just another machine on the network. Your computer actually has the IP address, and then let's just say this is your computer. It has the IP address of the DNS server. So it knows that. That's just part of what's in your computer right now. That's just the way these things work. And your computer either got that address by you typing it in manually, and 8.8.8.8 is a IP address that is a DNS server that I use. It's owned by Google, I think. And or you can actually get that IP address from your upstream provider. I've got to get some water. So whenever your computer does an IP DNS lookup, it can grab it from your router, the IP address of the DNS server from your router, which gets it from the provider that's providing you your internet access, and then your internet provider can then look up this address for you. And in order to do that, it looks in a master database, and these databases are called root servers. And these servers are pretty much the most important servers on the internet. They are used by everybody basically, and there's a whole bunch of them. I mean, there's like 20 of them or something like that. It used to be like 8 of them, I think, and then there's 16 of them. There's a good number of these, and they're also redundant, and then they're in multiple places. And everybody uses the root servers. The root servers actually just have a list of all of the domain names, like this, like google.com. And then what happens is when somebody like Comcast DNS service says, hey, I've got somebody asking for a Google domain, the root server will say, yeah, you go talk to Google. Go talk to this IP address over here. And then that guy knows what the IP address is of www.google.com. That's how DNS works. So there's another service that's very important, and that's called Aaron. And Aaron is responsible for, and by the way, DNS is sort of, Aaron and Internet used to be, these two guys used to be associated. I think they busted this up, I can't remember exactly, but basically Aaron and Internet were nonprofits whose jobs were to ensure that both IP addresses and domain names, the root servers, were run in a fair and ubiquitous manner such that everybody had equal access to them, and that there wasn't any funny business going on about advertising an IP address for a domain name incorrectly. In other words, so people couldn't scam you. So if you went to google.com, if you looked up Google's address in the DNS servers, you should find Google's IP address, and that whenever you're trying to route to that IP address, that your data actually goes to that IP address. So there's all this work behind the scenes on the internet that a whole bunch of different companies work on continuously, including Google and these guys, to be able to ensure that all your data gets to where it should be going when it's going there and when it's coming back to you, in theory. So where am I going with this? Okay, so if you have payment channels with Lightning, you actually have a situation, and we're just going to do a three-way setup. You have a situation where 3 IP addresses can open payment channels with each other. This actually forms what would be called a Lightning network, I guess. And probably each one of these has some sort of connection to a blockchain, like Lightning, or like Litecoin. So each one of these guys is capable of talking to a blockchain network. Now, it's not necessarily required. One of them could not have that, but on this particular portion of the connection, they're talking the Bitcoin protocol to the Bitcoin network, which is also IP based, I would point out. But it's done in such a way that the blockchain network, or the Bitcoin network, is completely separate. Again, it's that lower layer from the Lightning network. In fact, you could just say that a Lightning network could be created without the blockchain at all. Now, obviously, you wouldn't be able to embody the trust, the rational result whenever you arrived at it. But you could start up a Lightning network with this Lightning protocol with 3 peers, which is what we've got here. So that's what we're doing. And these guys can start, each one of them has keys. So I'll draw a little key here to indicate each one of these has keys that they can sign messages with. And they can pass these messages around any way they like. And these messages are all Bitcoin transactions or Litecoin transactions that they're signing. And inside of a Litecoin transaction or a Bitcoin transaction, you can put values, you have address destinations, and you have a text field, like a meta field, and we'll just call it a text field. So you have these things that you can attach to these transactions between these entities. So in theory, again, all of these things are encrypted, can be encrypted and signed and validated that they're coming from a particular party. So for example, and I'll number these, client 1 could send data to client 2 that was signed with client 3's public address, and then client 2 could send 3 a message with his public, it's encrypted with his public address that says, hello, it's number 2. Or I could embed that, so I could sign a message between 1 and 2, and then 2 could take that and then send it to 3, and 3 could validate that it came from 1. All I'm illustrating here is that these guys can talk to each other in a secure way. That's all I'm really doing. And it's all done over the internet. And it's all done by them knowing what the IP addresses are of each other. Okay, so that's what I'm talking about here. This is sort of an implementation, if you will, instantiation of the Lightning Network going on. And keeping in mind that at some point in time, each one of these guys or gals can choose to close the transactions that they're having and remove themselves from this group. This is a group forming a Lightning Network. Can remove themselves from the group and commit a transaction to the blockchain such that they make off with X amount of coin based on the conversations they were having of exchange of value amongst this network. All right, so what I am proposing that we do with the internet is that we take existing API providers who provide API services. When I was, actually right this second, my laptop is using a client called OBS Studio, and it has a key typed into it that then makes a call to the APIs on YouTube. YouTube does not, for whatever reason, they don't have a direct client that streams to YouTube. You have to download third-party apps, and that's the one I was using on my phone earlier. It doesn't work. I don't know what's wrong with it, but it's not YouTube, so whatever. But I'm able to use this one on my laptop, and it's making calls to the YouTube API. So one of ours is YouTube, right? And another one would be, I don't know, let's say AWS, which is Amazon Web Services. And then we need a client, and between the client and these two services is the internet. Or as Al Gore said, a series of tubes, right? There's a series of tubes that make up the internet, right? This is all the packets flowing, all of that stuff. And then you have clients out here. And I'm going to create two different types of clients. I'm going to create a client that is a live streaming app, right? So LSA is live streaming app. And the second client I'm going to create is a IoT device. Now, if you don't know what an IoT device is, well, it's an Internet of Thing device, and I actually have one on my desk. I don't have I probably can't turn it on. I might be able to turn it on. So this is an IoT device right here. This is a particle microcontroller with a LED ring, and whenever I plug it in, and it gets power. You see it flashing there? So it's actually logging on to the wireless network, and then when it starts spinning like that, that actually means that it's powered up. And I've written some code to do various and sundry things with it, and that's actually running a web server on it right now. This costs about, the ring is about $25, and the center unit on it, again, I'll kind of show you an image of it. The central unit on the particle device is actually about $25. The $25 device that you can buy and place on your wireless network in your home, and it gets internet, and it's able to talk to the internet, right? So IoT devices are a big deal. they're a big deal in startup land, and venture capital is really focusing on IoT right now. And the reason why is because all of the devices around your home are becoming equipped with these things like I just showed you, because they're cheap. In fact, I have one in the closet that I'm not going to fish out that would cost $5, and it does the exact same thing as this, except it's just a little bit more stripped down version of it, a little bit harder to code. But these things are, at the moment, highly insecure. The security that is being implemented on these things is not great, and that's because they're cheap. So if you were to, create, if as a company you were to create a device that was $1,000, like maybe a drone, for example, well, you're going to pay attention to the security of it because it's $1,000. Nobody wants $1,000 drones flown away from them because you wrote bad code. But if somebody buys a $5 IoT device and sticks it in their house and attaches it to their refrigerator, well, who cares, right? The company doesn't care. Now, you might care because you care about those things, but most consumers are not going to care about it, and that's why we're talking about an IoT device applying this technology to an IoT device using the Lightning Network, and what I'm proposing we build moving forward. So let's talk about our let me think about that. Our live streaming app first, okay? So we got a camera over here, and the camera is attached to, I don't know, it's attached to an IoT device too, probably, right? Eventually they will be. And it's got wireless in it, so it's broadcasting some wireless signal to your network. And it's running this live streaming app, right? And then what happens is it connects to YouTube's APIs. Now, before any of that occurs, just like this OBS studio I'm using to broadcast this stream right now, you have to transmit a key. And the way you get the key is you open up a web browser over here, right? And you go to YouTube's website and you scroll down and you click and look around, and if you're like me, it takes you 5 minutes to find it every time, and eventually you find it and you say, show me the key, and then you copy and paste it, and then you bring it back into your computer, and then you open your live streaming app, or you have to, type it in on your phone like I did earlier. And then what happens is now the live streaming app has this key that I pulled off the website. Well, all of that is just a giant mess, right? It's a mess to handle that stuff, and in fact, with IoT devices in general, it's impossible to do that today. There's no way that anybody's going to use that device. It's just too much trouble. If you spent $5 on it, you're not going to spend the 5 minutes it takes to do all of this with the key. So, but in this live streaming app example, this is what we did. And what happens is then that key gets sent to YouTube's APIs, and YouTube goes in and it looks in a database and says, I wonder if I can trust this key that this person just sent me. And then if they say, yes, I can, woo, then we're live, like I am right here, right? Then now you're able to see this data, and the data flows from my computer out into the internet to YouTube servers, and then from YouTube servers to your computer. That's how it all works right now, and it's all done with this key. Now, you don't need a key because YouTube provides public services for this, so they basically will give you the data for free, but that's an expense, and they would prefer that if you did that maybe you have an account with them. So I have a RedTube account, I think that's right. Hope that's not the porn site, but I have a Red YouTube account, right? And I pay $20 every month so I can watch videos that are interesting to me and without ads. So, I don't think my channel's popular enough to get ads on it yet, but if you were to connect to YouTube without having an account, then you might be shown an ad first, and that's how you're paying for it. So that's sort of how that works today. Now let's talk about an IoT device. Well, so these IoT devices can be set up by either wireless, which also requires a very similar setup process to this, or they can be shipped with a fixed key. Now the problem with this is, of course, is that number one, the fixed key can be found out by an irrational actor. And if an irrational actor gets hold of this fixed key, they may be able to hack the services that wherever they are. And I'm pointing at AWS here, but I'm not indicating that an IoT device could hack AWS. But you might be able to get into the IoT device if it publishes its address and it has a password, a very simple password on it, that exposes itself to the internet because it's out there trying to talk to services that are hosted on AWS by the provider in question. And this is exactly what has recently happened with millions of these devices. Millions and millions of these devices have been found to be insecure. In fact, they got so insecure of late that a white hat hacker, which means they, in theory, hack for good. In other words, they're acting irrationally by hacking other people's equipment, but their intent is not to spread the irrationality by hacking the equipment and making it their own. So this white hat hacker actually wrote some code that goes out and finds insecure IoT devices and then patches those devices if it can figure out how to do it. And then when it patches it, then the IoT device is no longer susceptible to being hacked. Other hackers, like black hat hackers, are actually hacking these devices and then using those devices to hack more devices to be able to grow their base. And then they take all of those devices and then they put in some plan of execution to gain value from people by hacking them. That's just what they do. That's their purpose here, I guess, as black hat hackers. So you end up having IoT devices having an insecure means by which they can not only get the keys that they need to talk to services like AWS. And why would an IoT device need services on AWS? Well, if it had a camera in it and it was maybe watching maybe the cat food bowl, right, to see if the cat food bowl was empty, to see if the cat needed more food, it might need some additional processing to figure that out. Maybe it needs a neural network or some AI to be able to tell the device what it needs to do, what action it needs to take. And if that is so, that device would then need to make a call out to some additional compute, or what we call an API method. All right. So now we've established that there are things out on the internet that need to make calls that use keys that are somewhat insecure and rather cumbersome to manage for end users. If we make things easier for users become more rational. If we make things harder for users to use, users become more irrational. So the upside of this is if we create services that are trustworthy, that are easy to use, that's a sort of a sometimes runs counter to development of software. But if we make something that's easy to use and is trustworthy, the net effect of that is the users will become more rational. They will act in a more rational way. In other words, they'll do less work. Everybody can sort of agree this is the amount of work that needs to be done to do these things. If I want to live stream, here's what I do. I know this is going to work. It's stable. And then you can grow your user base and you can charge people for it, right? So this is our overarching goal, is to make things easier for users so users become more rational with the services that we build. It's just a common sense thing to do. So in order to apply, now we've set out that the problem is twofold, that using things like live streaming apps, and these are just use case examples for what I'm going to present here, is that those are difficult to create and manage for users, and also somewhat insecure, and that IoT devices are difficult to manage their keys with, and also highly insecure because of their low cost. So what I'm proposing that we do is actually create initially a proxy service. And the only reason we're going to do this, and this proxy service has a name, it's called Wisdom, and that's the entire project and the proxy service. So I'm proposing that a company be built that's called Wisdom, that's my name for it, and that it creates a proxy service that runs as a SaaS, so software as a service. And this would feel a little bit like Apogee, which is a company that Google bought a while ago that acted as a proxy service for API calls. And that this proxy service sits in between the APIs of things like YouTube and AWS and the thousands of other APIs that companies use to build services and make money on those services. And what would happen is the clients would end up using this proxy service to talk to the APIs. Now, I'm not proposing that the proxy service remain in place moving forward. In fact, I would like to see where bits of this proxy service functionality are pulled out and run by other people, such as YouTube could run one themselves, so that you wouldn't need to make a call directly to the proxy service. But for now, we have to implement a proxy service in order to get this moving and getting it moving forward. So it's also a way to embody some trust in the system such that people can trust that the proxy service is doing what it says it's doing. Now, this proxy service, I'm going to go ahead and erase this part because I need the room over here. This proxy service is going to do something very specific, and it is going to provide a lightning network, which I'm going to denote here with this line. Maybe I should use a different color. So this is the lightning network section over here. So this is a lightning node, and there are other lightning nodes out here as well. And these lightning nodes are talking to each other inside of lightning networks, like what I described earlier. And then keep in mind that on the outside of this is, I have one more pin here, is outside of this is a connection to the blockchain. So these lightning networks have their connection to the Bitcoin or Litecoin blockchain. So there's, if we were to look at this, if I have room over here, you have essentially like a triangle here. And you have the lightning network in the middle, you have the Litecoin blockchain at the bottom, and you have this proxy service the Wisdom proxy service sitting at the top. That's sort of the way that this is built up. And this proxy service's job is to do one thing, and one thing only, and do it very well, and that is to implement the 402 payment required method. Now, most people know what 404 is. 404 is a HTTP response code that indicates a page is not found. In other words, your client, your web browser asks for a web page like www.google.com/blah blah 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 /foobar, right? And then Google replies to you, 404, I don't know what you're talking about. I don't have that resource available. So this service, if a client, which is sitting down here on the outskirts here, this client here, and this is the IoT device that we were talking about earlier, if it makes a call, if it makes a call straight to YouTube, and YouTube doesn't know who this IoT device is, and YouTube wants some money for that, for making that call for whatever reason, right? YouTube's like, I don't know who you are and you need to pay me. Then it could respond with 402 payment required. Now, today it doesn't do that, but that's the idea, is that the services will start doing this eventually if we implement this thing that I'm talking about. And the response would be, hey, you need to pay me, or at least authenticate. And the authentication one, I think, is 403. That's like, I don't know who you are. I think that's it. Could be wrong about that, but whatever. 403 is, I don't know who you are, you need to authenticate. 402 is, you need to pay me, right? Well, with cryptocurrencies, what's interesting about that is that you can actually pay for something at the same time you're telling somebody who you are. That's the cool thing about cryptocurrencies. So here in the Bitcoin blockchain or Litecoin blockchain, you actually have a means by which you can sign a transaction, send somebody something of value that you know that's their address, so you can go on their website and look it up, And you can send them that, and they can then, later on, you can send them another payment, and they know it's the same person paying. That's the way that Bitcoin and Litecoin work. So we can take both the 402 and 403 methods and collapse them into a single method, more or less. And so when I say we're implementing 402, I'm actually saying we're implementing a new way to pay and authenticate things on the internet. I am fast approaching my laptop dying, so I'm going to plug it in real quick. All right, we're safe. So in this case, what I'm proposing, if we would like to implement this without YouTube having to do a lot of work, is that the IoT device would actually call the proxy service. In order for this to work, the proxy service will also have to run what's called a registrar. And in that registrar, you will store two things. And hopefully I have enough room over here you can see this. You will store a payment address. So that's a payment address on the Bitcoin blockchain, so it's a destination payment address, and a URI, Universal Resource Identifier. URIs and URLs are very similar to each other. Universal Resource Locator. But a URI is a very specific thing. It says this. It gives you sort of like a protocol and a protocol and like a location is like a web address, and then I think a URI has the protocol on there. I think. Anyway, so URL, URI, whatever you like to think of it as. This registrar provides you this information. So if you would like to call YouTube with your IoT device, then you can simply look to see if there is a URL or URI in the database already that is in the registrar's database. And the registrar, I don't know what we're going to call it, so we'll just call it registrar for now. Maybe we'll call it LN registrar or something like that, right? And it contains the API endpoint that you're calling. So when you're calling YouTube's endpoints, they have something like upload stream, for example. And that's in their API docs. Don't take me literally here, it's not really that. But if you were to go look at their API docs, there would be a protocol and a endpoint, some name that looks like this on the youtube.com domain. I'll let that sink in. So you have an API on YouTube, which has an address associated with it, and a path, and a protocol that is taken and put into this registrar's database. So it's an API, and it indicates the payment address that is associated with that, which would be YouTube's Lightning network connection would be here somewhere, and initially this won't be this way, so it'll actually be hanging off of here. The payment address will be bound for here, and I'm going to talk about how we can hack up a solution here to be able to provide authentication, and then this information that contains what API you're calling. So let's talk about something very specific here, okay? So we're going to, on this other one, I'm going to erase AWS and I'm going to put Twitter over here. So this is Twitter's APIs. And you have another client who is just some random unidentified client, right? IoT device again. But this IoT device, it's like this one, right? All it cares about is how many times Cordless has tweeted in the day. That's all it cares about. Doesn't care about anything else. It just has, people buy these by the thousands. I'm just making up a use case here, right? And people buy these things by the thousands, and it has lights around it, and whenever a light lights up, well, Cord's tweeted 100 times. And it does that, and it goes up to 1,000 tweets, right? And so people hang these on the wall so they can see how many times Cord's tweeting. And this IoT device does not have a my Twitter credentials. So what I do is I go in, I want to sell this. I want people buying how many times I've tweeted from me. I want to sell that to people, and I'm selling the IoT devices too. So you get the Frio IoT device, and then you get a payment address, a cryptocurrency payment address, and then whenever you make a payment to that address, it actually pays the IoT device. The IoT device contains an address on it. In fact, if you look on the back of it, just pretend, you look on the back of this device, it has the payment address for it, which is associated with a key that's inside of this. That's the way it works. So I give you this, you pull out your phone, you make a payment to it, that goes into the Bitcoin blockchain. This device now has control of a couple of dollars worth of Bitcoin or Litecoin. That's what I'm proposing. Like, that's how the use case would actually work, is that people would pay based on this device. It's a payment address on it, which it has the key inside of it. Now, you're going to make it to where, like, if maybe you make these addresses to where if somebody pays too much to it, it gives them change. You can do that with Bitcoin. So there's ways of preventing somebody from sending too much money to this. It's a couple of bucks, right? They paid $10 for it. Maybe it was free even. Maybe I shipped it to them for free, and then it's got a payment address on it, and you make a payment to it, and now this thing is in control of its own wallet, okay? Now, whenever it gets fired up on the network, it makes a call to this proxy service because it actually looks up the payment address in the registrar first, pulls that out, and then it makes a call to the proxy service and says, hey, I have a destination endpoint that I'm interested in, which is all of Cord's tweets for the day. And the proxy service says, oh, you know what? I do know the payment address that you're talking about because Cord came in and created it. And that payment address that you're making, that you're wanting to pay, actually has some information associated with it, which I will now make sure that I'm going to run. And what it does is it fires up a container. Now, containers are they're little little bitty small programs that are fired up at will, and they're very quick. If you've heard of Docker, Docker is that technology that embodies containers. That's who does these things nowadays. And Google also runs some stuff called Kubernetes. Kubernetes does containers. So the proxy service runs a container system that is able to deploy containers on my behalf. Now, later on, as I said earlier, later on we can push this out to, if a provider like Google or YouTube wants to do this themselves, then they can do that, right? Which means that whenever that does happen, the eventuality of that happening would be that YouTube would be able to say, for certain payment addresses, like located on the back of this IoT device, I'm going to associate payments to this address with someone's credentials that I've already taken from them or their account. Now, keep in mind that YouTube already kind of sort of does this. If you go to YouTube's page and you're doing live streaming, you pay them, for the fancy Red account. Then they give you a key that you can then start live streaming, like I'm doing right now. I'm paying for this right with YouTube, but I paid them previously with a credit card. But what I'm proposing we're doing here is that we're actually paying for it while we're doing it, instead of it being done, post facto. In other words, like last month when I did it, and then be on a recurring payment with a credit card, we're actually doing it with the payment address that's inside this device right here, which means that I can send this device to somebody, they can make a payment to it, and then whenever it gets on the internet and makes a call to YouTube, right, that YouTube gets a little bit of the money and then sends me the rest of it. And that can all be done with the Lightning Network. That's what I'm proposing we do here. Now, I know that I'm probably not doing a great job of explaining this in a very clear and concise way. This is the first time I've ever talked about it publicly, in fact. I've talked about it with a handful of people on the internet. I've been thinking about it for a really long time. And I do believe that applying the Lightning Network to the rest of the existing internet infrastructure, initially by creating a proxy service, and long term by providing a registrar that associates payments with resources that companies provide to make their money, to do whatever it is they're doing with their particular business model, is the way that things will get done in the future with calls on the internet. Things like paying for articles on New York Times could be done. You could pay for allocation of AI processes running on someone's network. You could tell people that whenever they collect your private data, that it should be stored in a location of your choice in your home, or on a trusted network, or on premise in a company that you trust implicitly and rationally to keep your data secure and safe. It will allow you to revoke those trust levels as well later, as well as extend them into being processed by multiple services, all the while being able to pay for all of it while it's being done. If an AI process determines that you need additional storage for the video that you're streaming because it's important and being shared with others in the area, well then those payments can be changed through the Lightning Network. These networks are designed to be stood up by providers like YouTube, like AWS, like Instagram. They're designed to be run by people or companies who you already trust. And you may be a node on these networks, or you may use a service that is a node on these networks, but the idea behind it is to enable all of the calls and methods that are being made on the internet today via APIs through old, brittle security models to transition to using newer, updated models that are more trustworthy and that can be backed up by blockchain technology, which embodies rational trust for everyone. So we want to move us away from using irrational trust-based models like traditional API calls to using a more trust-based model like Lightning Network, which is built on rational trust models like Bitcoin and Litecoin. This particular technology can be applied to numerous things, and when I say numerous things, if you think about services like if this then that, where maybe you get a piece of email and a tweet, and then those two things are compared to each other, and then another action is taken, like a photo is uploaded, that type of behavior could be created with this network as well as the payments are flowing. And these payments can be very tiny, very, very small payments. We're not talking about $20 here. We're not even talking about a penny here. You can create a Lightning Network to exchange sub-penny values for the calls that you're making. And moreover, the calls that you're making, the revenue can be split and shared amongst the people that are involved in processing the data that is coming out of these devices, or in the data that's being published or pulled from these APIs. So you could actually create a public API that provides information about maybe government funding or spending, and you could allow people to take that data for a very small fee and add to it and allow them to charge their intelligence that they're adding to that, maybe through their experience or their knowledge in that particular area, and charge for that and turn right back around and offer that to your customers. So what this does is actually improves what we call the BD, or business development side of the internet business. All internet businesses would be able to do better business development with each other, because it would break down the barriers of implementing that software through a common framework. And I don't have a name for this framework. The best I can come up with right now is wisdom, just because it's knowledge based, right? It's applying payments to knowledge. It's applying trust and payments to knowledge such that people can exchange that knowledge for value. And really, the idea came about by just starting to mess around with cryptocurrencies and being from the infrastructure space. So again, I haven't done a great job of explaining any of this, right? That's not necessarily my strong point out of the gate, right? I get better over time as I explain this, and over time I will become better at explaining it, and hopefully others will also become better at explaining it as well. But if you're interested in it, well, that's why I'm making this video. If you're interested, or you know somebody that might be interested, have them drop me a line. I'm Cordless on the internet, Cordless. I'm at gmail.com. I'm also on Twitter that way and Instagram. Not much else anywhere else. I have a small presence on LinkedIn, but more or less I've unplugged from everything else. Those are my mainstays. If you want to get a hold of me, the easiest thing to do is email me. I'm around, and I'm thinking about this stuff. And if you think that it might be of interest to you, and you think that maybe your company could benefit from starting to receive on-demand payments as people are calling your APIs, you should give me a call, because I'm working on writing the software right now, and we should be able to go live with it within the year. So if it's an interest to you, you should give me a shout. If you like the video, give it a thumbs up. I make a bunch of other videos as well. I stream Rust, play Rust the video game, kind of explore alternate realities. I do a lot of philosophy, a lot of analysis of actions that we're taking. I'm a big digital detoxer. Unplugging from technology is very important to me periodically. And I talk about other stuff. So check out my channel. I fly a drone as well, and sometimes video. So anyway, check out the other videos if they're interest to you. Make sure you subscribe and stay up to date. I have a few subscribers now, and it's growing. So I appreciate you guys. Take care and have a good day.